Hey everyone, welcome to Dot Point A6, and today we're going to compare the proportions of bone, muscle and fat at various stages of development in an animal and relate those to consumer needs. So, to start with, we need to differentiate between what growth and development actually are. So firstly, growth is the increase in height and weight of an animal over time, while development is the change in the shape and the carcass composition over time, particularly the proportion of bone to muscle to fat, or the ratio of the tissues. Now, firstly, we'll look at growth. So what does growth affect? Well, it affects the time that you sell the animal, how long you need to grow it for. It affects the feed requirements and also the type of carcass produced. Next, we have fast growth rates are desirable so that animals reach slaughter weight as soon as possible. Animals have a higher food conversion ratio, leading to their fast growth rates, which means they don't cost you as much to grow if they're more efficient. And lastly, fast turnover of stock, so you can get more stock in to grow. Okay, so here's two different curves that you'll need to know. You'll often get asked these in exams or about them, or you might have to draw them. So the most common way of analyzing growth is to plot live weight up here against the age of the animal, and this is called a sigmoid shape. I've actually missed putting the word in here, but it's sigmoid, S-I-G-M-O-I-D, is an S shape, and basically it's similar for all species of animals. So here you have the animal being born at a certain weight, and then you have a very quick increase in weight, live weight here. And the time that happens is where what we term juvenile or puberty, when they're increasing very quickly. And this is the time here when their food conversion ratio is at its most efficient. They're putting on a lot of weight for what they're eating, so they're very efficient at this point. Once they reach maturity, at whatever age that might be, they don't really put on any more weight. They may put on a bit more fat, a small amount, but they've basically reached their peak weight effectively, and their food conversion efficiency after this drops off dramatically because they're eating food but they're not turning it into any additional weight. So that's the growth curve, or the actual growth curve. This one is slightly different. It's the growth rate curve. So it's basically the change in their the amount of growth each day. And so it's basically showing the same information, but it's the amount of change per day. So that's why it's the growth rate curve. And so at conception here, their weight increases per day. At birth, their weight's increasing very fast, and you can see they're increasing most per day when they're in the peak of their juvenile or puberty phase, and that's when they're most efficient. And then their food conversion efficiency drops off until they reach maturity. And so this is important for the producer because they want to really make sure they're selling the animal around this point here. If they're keeping the animal any longer, it's going to mean that they're feeding them a lot of food, which costs them money, but they're not getting any return for it. Okay, so the next point is growth can affect many aspects of production. Birth weight and mortality is one aspect that can be affected by low or high growth rates. So you can see this graph here from the textbook. You can see this is lambs and their birth weight and mortality. So the ideal birth weight is between 3.5 and 4 kilos for a lamb, because you have the lowest rate of mortality. If it's lighter, it's more likely to die because the animal might not be well enough developed to survive. And then it also increases again when the animal gets larger. And this is basically due to a thing called dystocia, which is written here. And dystocia is something you really need to remember. Dystocia means birthing difficulties. If the lamb is too large, it has troubles in birth, and that can lead to increased mortality. So a producer really wants to kind of make sure that the lamb is around the 3.5 to 4 kilo mark. All right, factors that affect growth after birth. Now, I'll leave you here to have a look at these, but there's a number of factors which you can get out of the textbook that affect growth after birth. And so we have the size at birth. Heavier animal at birth leads to a higher weight later on. The sex, a male tends to be heavier. Genotype, or the breed, obviously some animals can be heavier depending on their breed. Some of them mature earlier and are lighter. For example, Angus mature earlier and are lighter. The environment, which is made up of a few things such as nutrition, climate, disease and stress, all cause differences in growth. So the environment So nutrition, obviously, the more food and more energy an animal gets, the heavier it's going to grow, or the heavier it's going to get, and the faster it will grow. And the less food, the less growth. Climate, when animals are hot, they tend to stop grazing and seek shade, so they'll put on less weight. When it's cold and windy, they'll seek shelter and use energy for warmth, and so won't put on as much weight either. If they have a disease, their body uses a lot of energy to fight that disease, and the parasite, etc., may actually use energy from the animal, so that can be prevented by vaccination or drenching. And stress also causes an animal to eat less. So here's a question: under the conditions listed above, an animal's growth may be stunted. What effect does stunting have on production? Basically, bone growth might continue, but fat and muscle will be slower to develop, or might even stop developing because they're not necessary when an animal's putting its focus on something else or doesn't have enough energy. And this leads to large legs, a large head, and a small body. What we have here is some examples of different breeds of animals, and basically ones that are earlier maturing and ones that are later maturing. Now, the ones that are earlier maturing are going to end up being lighter, smaller animals when they are fully grown. The ones that take longer to mature tend to be ones that are larger animals and heavier, but they take longer to get there. So ones that mature early in cattle are Angus, Hereford a bit slower, and then Friesian and Charolais, the slowest of the ones here. If we look at sheep, Southdown is quite quick to develop and smaller, and then we have Dorset, Suffolk, Border Leicester, and lastly Merino, which take longer to mature. So this might be helpful later on if you get a question about earlier maturing or later maturing to do with genetics. This is not really to do with environment because they might all have the same feed, but it's genetics that causes that difference. Now we move on to development, and it's important to write here what development means. Hopefully you remember it from earlier on, but development is the change in the proportion of bone, muscle, and fat over the animal's lifetime. So it says here, essential tissue such as organs, and organs such as brain, lungs, heart, skeleton, and muscle systems are well developed at birth, obviously to ensure its survival, and then reproductive and fat systems develop later. So we can see here, initially you get head, brain, kidney, and kidney fat developing, then you get bone and intermuscular fat, and lastly muscle and subcutaneous fat developing all the way from conception through to maturity. So that's the order in which they develop. So if you first have bone, and then you have muscle, and then you have fat developing in that order. And you can see that in what an animal looks like at various stages. So initially, a calf is going to look like it has a lot of bone. It has long legs, a large head relatively. That's the result of bone growing first. Then you start to get muscle put on as the animal gets older. And you can see the muscle definition in these two animals, the young bull and the vealer. And then lastly, the last thing to be put down is fat. And so the mature bull is going to have a significant amount of fat, whereas a calf won't have much at all. So if we have a look here, summarize the section on postnatal growth and development below. Postnatal means after birth, and basically the essential organs develop first. You have the heart, the kidney, the lungs, intestines, etc., and then your reproductive organs developing later. Then the carcass, that means therefore the carcass of a young animal will have a lot of bone, intestines, etc., which are considered waste products. So if an animal is slaughtered young, there's a lot of waste that is not wanted by the consumer, and they won't pay much for. And so they develop in the order of brain and nerves, then we have bone, then we have muscle, and then we have fat. And so if we have a look here at this diagram, which you should have copied out of the textbook, as nutrients increase, more and more nutrients means the animal can do more things. So you might have maintenance energy down here, but once you start getting production energy supplied, the animal can then put on muscle and fat. So it will put on brain, eye, and nerve tissue, and then bone first, and then the more and more energy or nutrients you supply to the animal, it will then put on muscle, and it will then put on fat. So to get up here to this muscle and fat area, you really need to be feeding the animal maintenance energy plus production energy, which is more on the top of maintenance energy. Okay, so when an animal gets enough nutrients to survive, ME, this actually should say maintenance energy. I wrote the wrong thing there. It should be maintenance energy, ME. and a high enough amount of additional nutrients, PE or production energy, which I just said before, they can put down fat, which is stored energy. And so with increasing amounts of energy as an animal gets older, it can start to put down fat. And so the order it does that, first it puts it around the abdominal area, so kidneys, intestines, etc. Then it puts it in subcutaneous, meaning under the skin, so outside the muscles but under the skin. The third place it puts it is intermuscular, which is between the connective tissue. And then lastly, it puts it in intramuscular, we know as marbling. So within the muscle or meat fibers, it gives you white creamy patches of fat scattered through the meat, and it gives it flavor. So that is what marbling is. The last point here is, how does farmers use this knowledge to meet consumers' demands? So basically, consumers demand certain qualities in meat, and they are willing to pay a higher price if they're met. And to modify the carcass components will allow the farmer to maximize their margins. So the carcass is the most valuable part of the body. There are other parts which are removed at slaughter, such as the head, feet, heart, hide, lungs, etc. And the leftover is the carcass, which is what's going to make the most money. Basically, the carcass consists of muscle, bone, and fat. And what you want to try and do with the carcass is provide maximum muscle, optimum fat, and minimum bone. And you can see here, this is what's called dressing percentage, which means the carcass weight over the live weight. So it's the remaining amount of carcass weight compared to what the animal was when it was alive. And you can see that cattle end up with about, give or take, 60% dressing weight. So 60% of the live weight is actually carcass or really high value meat. And sheep get kind of around 50% plus or minus. So, 40, 45, 50%. So this means a lot in terms of their efficiency. Cattle are more efficient because you get more of the animal saleable as a carcass. Okay, so as we said, an ideal carcass has maximum muscle with some fat, depending on consumer preferences, but minimum bone. And as we'll talk about in a second, some markets prefer more fat than others. And those last two components, fat and bone, make up the less valuable part. Obviously, the muscle or the meat the beef is worth the most. So beef producers use this knowledge to manipulate growth to best fit market specifications. Consumers these days are looking for things that are hormone-free. Hormone growth promotants is something we'll look at shortly in another dot point. Consumers are after lean meat cuts with minimum fat and ones with consistent quality. And so this is just something you should definitely remember, these two here, because you might get asked about these. Name some markets and their consumer requirements in terms of carcass weight, bone, muscle, and fat. So firstly, we know about the Japanese market, and I've chosen these two because they're kind of opposite to each other. The Japanese market that we supply to our cattle, say Wagyu or other animals, other breeds, they prefer a heavier, more mature carcass because they prefer a higher fat percentage and often marbling. So to get an animal, a heavy carcass, with a higher fat percentage, it's going to be older animal and it's going to be heavier. On the other hand, the Australian domestic market, particularly supplying supermarkets, require younger animals. The meat's a bit more tender. They have a lot less fat, lower fat percentage, so the animal is a lot lighter. Okay, so onto HSC questions. You can see here the question is, which of the following graphs show the correct order of development of tissues during an animal's life? So it's a multiple choice question. We already know that the first tissue put down is bone, and then muscle, and then fat is the last tissue to be put down. So we have 3 here in the correct order. So that is pretty easy. That is A. The next one, for a named farm animal, explain why protein requirements are different at 2 different stages of an animal's life. So I've named a chicken, and it's a monogastric, so putting this extra information in here is a good idea, so the markers know that you know what you're talking about. And then I've written when a broiler or meat chicken in their first 2 weeks of life, their muscle growth is highest. And so we're focusing here on protein requirements, remember, at 2 different stages. So first 2 weeks, first stage, and muscle growth being the highest. This requires a high level of protein. As we know, muscle growth requires protein from protein consumption, and hence starter ration contains high protein up to 23%. Okay, the second stage, the last part of the question, 2 different stages. The second stage is on the finisher ration from weeks 6 to 7. Remember, a broiler, we learnt before, only lives for 7 weeks and then is slaughtered. And they have slowed muscle growth and increased fat deposition at this point. So the protein amount in the feed would drop to 10 to 12%. I haven't gone into any more information about fat deposition because the question is about protein requirements, and I'm wasting time and space by if I was to go into fat. So it's really just after protein. If we have a look here at this question, it says a farmer observes daily milk production for cows, decides to record milk yield per cow over time, and the summary is shown here. So we have the Holstein breed eating both pasture and then also pasture and grain, and Jersey breed the same. So two different breeds. This is genetics, and what they eat is basically an environmental factor. And here we have an average, and hopefully this is over a large number of cows to improve reliability. And you can see there's a difference. When they're on grain, they are putting on, or they're producing more milk per day, quite a bit more, 6 litres per day. And the Jerseys are producing more as well. So the feed or environment is having an effect on the daily milk yield. And the question is, which of the following correctly reflects these observations about the milk yield? We can also say that if we look at pasture only, Holsteins produce 32 litres a day and Jerseys produce 26. Whereas if we look at pasture and grain, it's 38 versus 30 for Holsteins versus Jersey. So genetics or breed is also playing a part. So the only one here that's correct is it's influenced by both genetics and environment. If we move down the page to this next question, the graph shows the relationship between carcass weight here and fat percentage. So as the carcass gets heavier, the fat percentage is going to increase, which is what we know as an animal is becoming more mature and heavier, the fat percentage will increase, it will become fatter. So how can the information in the graph shown be used by a farmer to produce animals to suit a particular market? 2 marks. So we saw before the examples I gave you were the Japanese market and the Australian supermarket market. And so the graph shows that lighter animals down here will have lower fat percentages, and heavier animals will have higher fat percentages. An example of using this could be selling lighter animals to Australian supermarkets, which like lower fat percentage, and heavier animals to Japanese market, which like higher fat percentages. This one's just a simple calculation one, but it's kind of related to this dot point. So you just need to calculate about that, but the answer is C. This one, on the Board of Studies website, this picture was not available, so I actually substituted in a picture that I found. So that pretty much matches the question pretty well. So animal 1 and animal 2 were provided with the same level of nutrition. This is important, and this question is really focusing on the genetics versus environment thing we were talking about before. Remember, nutrition is an environmental factor, and they were given, both animal 1 and animal 2, given the same level of nutrition. So the photographs from the carcasses were cut at the same site, show the components of body tissue, remember tissue being bone, muscle and fat, and their proportions. And I think the thing we can notice here that's different is the fat level on both of them. Okay, so name one component of the body tissue labelled in the photographs and account for the variation of this component between animal 1 and 2. Now, the one we're going to look at here is fat, because it's basically, we can see muscle, but the one that we can see is very different is fat. So fat, and particularly marbling in the middle of the meat here. So we need to account for why there is variation. Now, you might say that they've had different levels of nutrition because for an animal to marble, it needs to have grain. So you could potentially say that this animal's had grain and this one's just eaten pasture. But it says here in the question that that's ruled out because it says they had the same level of nutrition. So the only other explanation is, since we've ruled out environment or nutrition, the only other explanation is genetic, and that basically means it's a difference in breed. So we know that some animals will marble, some breeds, and other breeds won't. And an example of a breed that will marble is Angus, and one that won't so much or won't is Hereford. So animal 1 on the left is showing an increased marbling or intramuscular fat amount, and although they've been fed the same level of nutrition, the difference is likely due to breed or genetics. So you're showing here that you have an understanding of genetics versus environment, and that you've clearly stated that it's genetics or breed here that's caused the difference. Animal 1 could be a marbling breed, such as Angus, whilst animal 2 may be a non-marbling breed, such as Hereford. This is really, this last sentence, just to show that you really understand what you're talking about, and it's really guaranteeing you the third mark there. If we have a look at this question from 2010, it says, explain how the nutritional requirements of farm animals can be managed to influence their growth and development. So straight away it says and. You should highlight ands, and we need to talk about growth and development. So what I've done before I wrote anything else, I wrote growth and I wrote development. They were the first two things I wrote, and then I went about talking about each. Because it's a 6-mark question, you're basically getting 3 marks for each one. So if you forget one, you can't get more than 3. So what I've done is I've talked about growth and I've talked about development. So growth, explain how nutritional requirements can be managed to influence growth. So change in height and weight over time is what growth is. It's good for you to repeat that so it shows that you know what you're talking about. Increasing energy and ensuring enough maintenance energy and production energy through a well-designed ration and supplementary feeding if pasture is not adequate. This will ensure enough energy for growth and not cause any stunting. Healthy weight of calf at birth gives you better growth rates, which we learnt earlier. So that's definitely 3 marks there so far. Development, again, it's good to put what it is so that the markers know that you know what it is. Change in proportion of bone, muscle and fat. This can be done through changing of diet components over time. Remember, we could put breed here because that can change the proportion of bone, muscle and fat, but it doesn't say breed, it says nutritional requirements. So we need to talk about the feed. This can be done through changing of diet components over time. Example, high protein diet early on for muscle growth with good quality lucerne, etc. And high energy diet at finishing for increased fat when you don't need as much muscle. If we move on to the second last page, we have here a chart of live weight of ewes that are pregnant and the lambing percentage. Now, the lambing percentage means the amount of live lambs born over the total number of lambs born. So it's basically mortality rate or the opposite of mortality rate. So the amount of lambs that survive birth. And so here, what we need to do here is look at how many lambs survive in the percentage. So firstly, let's have a look at the question. Describe the effect of live weight of ewes on lambing percentages as shown in the graph. So ewes, mothers that are 55 kilos, have about 95% of their lambs successfully born, which is almost all of them. If they're lighter, they have less, and it drops off again if they're heavier. And this is probably due to the fact that the mothers just aren't well enough. They don't have enough nutrition. Their body condition's not very good to be able to support a lamb, so they're more likely to die here. And if we look up the higher end, maybe the animals, the mothers, the ewes are fatter and they have birthing difficulties, which is called dystocia. So optimum weight is 55 kilograms. Lower leads to higher mortality as likely the ewe is in poor condition, and a higher weight leads to birthing difficulties. This one, explain how information in the graph can assist farmers to manage ewes in order to maximize lambing percentages. So farmers should really aim to keep their pregnant ewes around 55 kilos. This leads to almost 95% of lambs surviving. That's the effect of doing that, cause and effect for our explain, and it will improve profitability of the enterprise, which is a good thing to add in as well. Okay, the last question. This is kind of related to the dot point, and it's thinking outside the square a little bit. The diagram shows 2 equal sized pens. A feedlot steers and gives average growth rates obtained over 100 days. So you've got pen X with more cows. So there's 3, 4, 5, 6, 7, 8, 9, 10 steers, whereas over here we've only got 5. So there's half as many, and there's also shade in there. And so we know that if we have this double the number of animals competing for the same amount of food, that's the first thing that's going to, or the question is propose reasons to explain the difference in growth rates. And the difference in growth rate is pen X is only putting on 0.75 kilos a day, pen Y is putting on more than double that at 1.8. So you've got half the number of animals over here competing for food. So that's the first thing. they're going to get more food, higher growth rate. The second thing, really the only other difference, is these ones have shade, and so these ones are going to be less stressed and more probably eating more each day. These ones are going to be facing heat stress, and when they're hot, they don't like to eat as much. So that's the second point here. This is 4 marks, probably 2 marks for each one. Pen Y has shade, meaning animals face less heat stress and hence likely eat more, leading to increased growth.